Hello everyone, welcome to this video. In this video we shall be looking at a question from IIT-JAM 2018 consisting of 1 mark. This is a numerical type of question, so you are to input a numerical answer over here. So here the question is that the function phi, which is a function of 3 variables x, y and z, is given to be this one, 3y square plus 3yz, where these x, y, z, they are this is some point in the three-dimensional space. Then the absolute value of the directional derivative of this function phi in the direction of this line at the given point is what? So this is the question. So now the first thing that you are required to know over here is the formula for calculating directional derivative. This is the first requirement. So let me tell you that quickly. The directional derivative of some function, say I'm calling that to be phi, in the direction of unit vector. So we require unit vector, which is I'm calling that by u cap, at the point P. So you see, in the calculation of directional derivative we require three things. One is the function itself, another thing the unit vector, and third thing is the given point. So in that case the directional derivative is calculated when you compute the gradient of this scalar function phi at the point P, right? And then you take the dot with the unit vector. So this is your directional derivative. So you must know this formula. This is first thing. Another thing here, if you notice that in this question you are given this phi is given to be 3y square plus 3yz. Okay, we are given the point, so I'm calling that point by P. So the point P is given by 1, minus 2, 1. So this is also given. But what about this unit vector u cap? That is not directly given to you. But in the question they are saying the direction is given by that of the direction of this line. So here we are to compute what is the direction of this line. And from the direction of this line we are to compute this unit vector. Right, so this is the task and the catch here in this particular question. So now if you look at this line over here, so the line is given to be x minus 1 divided by 2 equal to y minus 2 divided by minus 1 equal to z divided by minus 2. So this is the line. So if you can clearly see from here that what are the direction ratios for this line. The direction ratios, they are given by these quantities, right? So they are 2, minus 1 and minus 2. So usually you write them by angle brackets. So these are the direction ratios for this given line, right? So what could be the vector in this direction? So the vector in this particular direction would be given by, suppose the direction ratios are given by A, B, C, then the corresponding vector in that particular direction would be given by AI cap plus BJ cap plus CK cap. So accordingly here in this case our vector would be 2I cap minus 1J cap minus 2K cap. So this is the vector in whose direction we are to calculate this directional derivative. But now the point is we require unit vector. So that means your unit vector, say u cap, would be this vector divided by its magnitude. So how do you calculate the magnitude of a vector? You just take the square root of the sum of the squares of each of these components. So it would be 2 square plus minus 1 square plus minus 2 square. So it would be 4 plus 1, that is 9. So when you take square root, so it would be 1 by 3 2I cap minus j cap minus 2k cap. So this is the required u cap vector. Now we have all the three components. Therefore, what would be your directional derivative? So your directional derivative would simply be given by this formula. The gradient of the given surface calculated at the point P dot with this unit vector, right? So firstly, let us compute this gradient of this given surface phi. So this is the given surface phi, 3y square plus 3yz, right? So our phi is 3y square plus 3yz. So what would be the gradient of phi? So you know what is this del operator? So this is del by del x I cap plus del by del y j cap plus del by del z k cap, right? So this is del, and what is phi? 3y square plus 3yz. So when you compute this derivative, so it would be del by del x of 3y square plus 3yz I cap plus del by del y of the same quantity, and then del by del z of this same quantity, right? So let's calculate the derivatives. In the first case, it is going to be 0. In the second case, it would be 6y plus 3z, right? And in the third case, it would be 3y k cap only. So this is the gradient of the given surface, the given scalar function phi. So let's compute the scalar function at the given point P. Now what was P? Your point P was 1 minus 2 and 1. So we are to compute this at the point P, which is 1 minus 2 and 1, right? So when you substitute here the value of 1 as minus 2 and the value of z is 1, so you will obtain here the vector. So it would be minus 12 plus 3, so that would be minus 9 j cap minus 6 k cap. So this is the gradient calculated at the point P. So we have this quantity, let's substitute it back over here. So therefore your directional derivative, let me call that by dd, your directional derivative would be gradient of phi calculated at P dot with u, so it would be minus 9 j cap minus 6 k cap dot with u cap vector, which is 1 by 3, right? And you have 2 I cap minus j cap minus 2 k cap. This was your u cap vector. So you just have to take the dot product here. So it would just be 1 by 3, and then you have plus 9, and then it would be plus 12, right? How do you take the dot product? I with I, j with j, k with k. So therefore it would be 21 by 3, which is equal to 7, right? So your answer here, the value of directional derivative is equal to 7 over here. So your final answer is 7, right? So I hope you understood this question well. Well, that is it for this video. Thank you for watching.